We're going to talk a lot about the fleet assessments and how to deploy these technologies. I had the opportunity at UPS to do this worldwide, so it really is something that I near and dear to my heart, and something I hope that people that are going to be involved in this are really going to take it seriously and make sure that you need to start with the very basics of your fleet assessment. And when I talk about that, we talk about things like duty cycles and right vehicle for the right route. You see a simple electric bicycle that we run in Germany, and we just decided that was a lot easier than bringing package cars in. And there's many places in Germany that have non-pollution zones all day long, meaning you could bring trucks in from 2300 to 06, but during the daytime you can't bring anything in 1 square mile. So you hire industrial athletes on bicycles to solve the problem. So I mean, there's a lot of things that we could do with the technologies that are available, but we need to make sure we get a good fleet assessment, because your current fleet composition, what you're doing, is really, really important to the fleet assessment. And if you don't have somebody outside looking in, if you have internal assets, industrial engineering assets that are looking at it, that's fine. But if somebody from the outside isn't looking in, you may not understand that you're doing things wrong. And I tell you, we've done this with a lot of different companies. UPS did a lot of acquisitions over the years. We look at the company and we just say, how are you doing this like this? Well, we've always done it like that. And that's one of the things that you really need to make sure that you're doing the right thing right now with your current fleet. I think that there's a lot of professional organizations out there. G&A is one, CTE is another one. There's a lot of other consultants out there that will help you with this. But it really is an important part, because you can't make that wrong turn early on, because then your deployment might be worse with your alternative fuel vehicles or your activities to get your emissions reduced. I just wanted to mention, I have a couple of slides in here, and these are just cool things. There's a little Ducati, and you can see this Ducati is a lot smaller than a bicycle. So you could have this thing run in and out, and it could do deliveries on sidewalks, just things of that nature. Again, just thinking out of the box. And again, zero emissions, zero tailpipe emissions. Of course, it costs us some carbon to get it charged, but it's just another way to deliver those packages, or to complete your company's duty cycle, whichever way you're looking at it. And when I get into duty cycle, it's again, there's loads out there that are not optimized, and really you have to optimize those loads right now. The duty cycle of a vehicle, whether it be a dump truck or it be a package delivery vehicle or a food delivery vehicle, they need to be optimized. And that's the most important thing, because if you're not optimized right now, again, you may purchase 2 or 3 times more equipment than you need to get the job done. And at the end of the day, we want to get the job done. We talk a lot about these technologies, and always in my mind was always the fact you can't go broke going green. You need to make sure that you're doing these things in a fiscally responsible manner for your company, for your shareholders, and otherwise companies that aren't going to be fiscally responsible just won't be around. They'll have a bunch of electric trucks that won't be delivering anything. Performance. When we talk about performance, this again, when we talk about your current fleet's performance and the fleet, the technology you're going to want to choose, but performance is really, really important, and it really needs to be really scrutinized. There's a lot of people that let some performance measures just blow over, whether it be an inverted number on MPG, or whether it be an inverted number on duty cycle, meaning when the vehicles are available, uptime. It's really, really important to get the correct performance numbers in there before you even think about going to a different type of technology. Then maintenance. And most engineers really think there's a long pole in a tent, and it really is. At the end of the day, maintenance is a huge part of this. If you're currently insourcing maintenance and you have to outsource maintenance, the economic problems with that are going to be tremendous. So you really need to make sure that you're prepared to either conduct your internal maintenance, and you get into these different technologies. Of course, electric, high voltage, a whole nother acumen that the technicians need to learn. When you get into hydrogen, CNG, high pressures, high pressure vessels, more acumen those technicians need to learn. And of course, you get into shop configurations. There's requirements in shops for different fuels that need to be met And the fire marshals will tell you all about it, but you need to be thinking about all in the front, because the maintenance side is very, very important. Or you just farm all the maintenance out if you have a good W.W. Williams near you or something like that. But I mean, if you don't, and you have to do it inside, you have to really give these considerations. And then the fleet assessment continued. Again, this is all part of the fleet assessment with the maintenance involved. And then, of course, the infrastructure requirements. The infrastructure is pivotal, and it's geographic in nature, meaning that if you're in an area where you don't have the right size natural gas lines and natural gas pressures, you can never have a fast fill station, ever. You can only have a slow fill station. Or you could go ahead and spend $1 million a mile to make those lines meet your requirements. But again, you need to assess all that. If you're in an area where there's energy mostly produced by coal, and your objectives are to go ahead and reduce carbon, well, you know, that's a whole other set of problems. You need to go ahead and make sure you're looking at the infrastructure, and never ever jam the square peg into the round hole. You got to make sure that what you have there, it might be different for your California operation versus your New Jersey operation. So just very, very important that's always completed. And again, the external consultants will be looking at all this. If your internal team has it, by all means. And the last report that Joe put up there really had a lot of good information in there to follow. Then it gets into testing, and at UPS, we tested things worldwide. Again, I felt like I got a PhD in advanced propulsion vehicles because everybody in the world wanted to sell us stuff. People in Singapore, people in China, people in Japan, of course in the US. So I mean, you got to look at these technologies and evaluate them. But the thing was, we went ahead and we did the 10 vehicle test. And the reason why 10 vehicles is pretty simple. If you only do 5 vehicles, and most of you fleet operators know, you're going to have 5 to 7% downtime. You're maybe going to have an accident with a vehicle. And then you might have a vehicle that just is not performing because they're all newer vehicles. So if you have 5 trucks and 3 go down, now you're testing 2. So if you have 10 trucks and 3 go down, at least you got 7, so you still got a real good picture of what these vehicles can do in your fleet. And again, I'm not trying to pick any winners and losers, but when it comes to the technology, and no state entity should do that, as we know some states do that, that has to fit your business vocation and your geography. When we get into fuels, and this is something that I really spent a lot of time on with fuels, there's so many different opportunities, and again, Joe touched on them, but you know, propane's, we've been using propane in Canada for the last 50 years. I mean, propane's been used in a lot of places in the U.S. for the last 50 years. Propane's a great fuel, but you know, obviously it has some carbon associated with it. But renewable propane is a whole different animal. Now, it's not as abundant as propane, but renewable propane just changes that whole emission profile. Same with RNG. I mean, there's other fuels out there that really do a really aggressive job. And again, you don't have to put in a $7 million CNG fast fill station. You put a propane station in for about $250,000. You know, gravity fill almost. So I mean, it's really just different for what your vocation is. Typical Class 6 UPS operation, 100 trucks. They do 100 miles a day. You have 6-liter propane vehicles there, and you're having renewable propane. Your carbon profile just went upside down completely, you know, from a gasoline vehicle. And of course, you don't have all the money. If you try to make it a full battery electric operation, 100 miles a day, you're marginal with Class 6 today. A lot of Class people say they're getting there, but they're putting 135 kilowatt hours on to try to get 100 miles. And that's if your driver's a good driver. If your driver's a bad driver, they're responsible for about 35% of your fuel economy, whether it be any type of technology. So you could be getting 70 miles a day out of those trucks. So I mean, there's a lot that goes into that. And again, the engineering side of it, and I hate to use the word industrial engineering because it's really automotive engineering, is really important. Put all that time and effort up front, and then the deployments would be so much easier. These are just few examples of fuels. The renewable hydrogen, Joe talked about that. Making fuel from cooking oil, people have been doing that for quite a while. And then SAF, I just wanted to mention sustainable aviation fuel. This is one of the biggest things going on in the country right now. So this is laboratory grade fuel, all SAF. And of course, the U.S. Air Force is involved, all the major airlines. But again, if we could produce that fuel through a chemical process in a laboratory, and it's perfect fuel because, you know, a lot more volatile at 40 degrees below zero when you're doing 565 miles an hour over some mountains. You want to make sure that there's no water in that fuel. Battery electric vehicles, I'm just going to get real quick. I know that Joe talked about some pros and cons, but the thing about them is obviously the tailpipe emissions, very quiet, high torque. High torque can be a dual-edged sword. You got to make sure you only give the driver what they need. Never give them more than what they need. Otherwise, you'll be replacing tires every 3 months. So you just want to make sure again, an engineering process, you want to give them their capability that diesel affords them right now, but you don't want to give them anything more because they don't need it. If they need it, you give it to them. If they don't need it, you don't give it to them. Cons obviously are and I talk a lot about geography, and Southern California is a perfect place for electric vehicles. It doesn't rain, so you don't use wipers. You're not using the defroster. You're not using your heater a whole lot. An air conditioner is a lot less energy dependent than a heater. In an electric vehicle, heaters just eat up your power. With an air compressor, you just turn a little air conditioning compressor, and you could get some very, very efficient ones. But if you're doing that same operation in Chicago, when it's 9 degrees 6 or 7 days in a row, well, you're number one, you're never going to get full charge on your batteries. Your battery, lithium just doesn't charge at 9 degrees. You'll get 60, 70%, but you'll never get up to 100%. Your discharge rate is going to be so fast during the usage. Again, that cold just eats it right up. And then the drivers are going to want to turn the heat on. So, a truck that we plan to do 100 miles a day might be doing 25 miles a day. And you can't have a spare set of trucks to do the work of those trucks. So again, very, 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 very dependent on the geography. There's a lot of cool things, these solar charging stations. And by the way, I went by the free charging, level 2 charging station on the way over here. Walking, I couldn't believe, I'm looking for the credit card input. There's no place to put a credit card in. If I lived here, both of my cars be charging over there every single day. There's no reason why one of those stations should be empty. That's a wonderful thing that they're doing here in Baton Rouge. But solar panels are a real important part of it. I think that we need to make sure that we're appropriate. And again, you can't put a solar panel up anywhere you want to. You can't put solar panels up in Ontario, California because of the Santa Ana winds, unless you build a specific structure for that. I mean, you just can't pop them on your roof. So there's a lot of things, a lot of places solar panels, and of course places that don't have sun. Syracuse just doesn't have enough sun for solar panels to be cost effective. BEV's fast charging, when I was at the IAA in Hanover, they're building 1 megawatt chargers. That's a tremendous amount of energy for Class 8 trucks, 1 megawatt. This happens to be a MAN, and you can see that they have 2 level 3s on here, but there's chargers right now, the Tesla charger for their Class 8, that's 500 kilowatts. I mean, so it's a lot of doggone energy that goes into these vehicles. Nat gas, and I'm a big fan of nat gas. I've been using nat gas for many, many years at UPS. It just is a good, clean fuel. RNG is obviously better, but nat gas is really, really a great fuel. And Pat's going to talk. Pat's a subject matter expert in power plants. He'll be talking about nat gas and some of the other fuels. He'll get deeper on that. So it really is a great product, and again, great for the refuse industry. And of course, they produce RNG, the refuse industry, so it's a win-win for them. Then I mentioned fast fill or slow fill. The refuse industry can use slow fill, along with city buses, and there's other vocations that can use slow fill. But it's so much better for the vehicle to slow fill. Tanks, you put 3,600 PSI, if you're putting it in quickly, there's going to be expansion. Because when you're using it, you're always taking it out slowly. The best way to fill up a high-pressure vessel is slow. The best way to discharge a high-pressure vessel is slow, whether it be hydrogen, CNG. It's just so much better. So their vocation is just perfect for this application, just absolutely perfect. And LNGs, we've been using LNGs for many, many years. And of course, that's just a matter of fuel. What kind? In Florida, we use LNG because the CNG pipeline doesn't go all over Florida. So we have LNG tanks up, and and these are spark-ignited LNGs. The old LNGs were fuel injected, and Pat might even want to talk about that a little bit. And they were just a different animal, but at any rate, these LNG tractors do a great job for us, and it's just a great technology. You get a little bit different carbon penalty between LNG and CNG for some political reasons, but they're both very, very clean fuels. Fuel cell electric vehicles. I had the opportunity to work on fuel cell electric vehicles since about 2003. and this is really, I think, the Class 8 pathway. There's no doubt that you're going to get the range out of this. Obviously, you're spending a lot of money on a fuel cell. You're cutting out some battery. And again, this gets into arguments because Tesla makes batteries. Tesla's not interested in fuel cell vehicles. They want more battery, less fuel cell. With your vocation, and particularly Class 8, over 500 miles a day, which a Class 8 should be doing. A typical diesel Class 8 in a good operation does 1,000 miles a day. I drive it, from 6 in the morning till 4 in the afternoon, pack it in at 6 at night, and drive it to 4 in the morning. That's a good operating Class 8 diesel. So again, 500 miles, you're going to be, I'll do 500 miles, 10 hours, 50 miles an hour. He'll do the same. That's full utilization of a truck. You can't have a truck charging for 6 or 7 hours or 8 hours, not turning the wheels. If the wheels aren't spinning, not making any money. So that's why I think fuel cell vehicles really have a really, really great future. This is a really cool one. This will be at ACT. The Toyota Kenworth product, two of the best minds in the trucking industry, obviously Kenworth, and the Toyota engineers just heads above everyone else. Really, really cool product. I just wanted to show this Mercedes-Benz, and again, this product was over in Hanover, and in Germany, and in the EU, they're going to be pushing a lot of effort into hydrogen. When we were there last year, again, about 30% were BEV in Class 8. Class 5s and 6s, they higher BEV, but they understand that hydrogen is going to have to be the way to go. Not only because it's easier for them to move hydrogen around, but they just don't have the infrastructure that we have. I mean, the lights will be going, lights can't be flickering on all in the whole EU because you're charging 4,000 tractors. So it really is it's going to be an interesting pathway. But again, my personal opinion is that Class 8 heavy duty will probably move more towards hydrogen because you just way too much battery. Alternative. I mentioned earlier that the greenest mile is the mile never driven. So again, engineer out all the waste before you even start with your alternative fuel fleet. You got to engineer all that away. Idle time, things like that just aren't productive. You got to try to engineer them away. These bicycles are electric assist bicycles, and they're just another way for people to deliver goods and services. And if you could go ahead and do that, you hire a couple of industrial athletes. They hop on these things. You zero emissions, and all you're doing is a little bit of carbon. They're like 11 kilowatt-hour batteries. So there really is a real way to really look at different ways to deliver your goods and services. Pat's going to cover quite a bit of the power plant portion of this, and I think that if I let Pat go right now, and then you could ask questions at the end of it, he'll probably answer a lot of questions. Okay, so thank you, Ann.
Very good. So thanks, Ann, for the invite, and thanks, Mike, for the setup. So I want to talk a little bit about the strategy drivers behind what Cummins is up to. So starting on the left and going clockwise, NOx reduction is a big darn deal for the trucking industry, especially diesel. The reductions between CARB and EPA between 2024 and 2027 is between 75 and 90%. So we're going from 0.2 grams of NOx to 0.035 and potentially 0.02, which is just a massive change in the NOx rules. Greenhouse gas phase 2 and 3, that's basically an improvement in fuel efficiency for Class 8 vehicles, and is actually sort of the inverse of what you do with NOx. It's kind of hard to hit both things at the same time, so it's very much a challenge. ESG, environmental, social, and governance, a non-financial metric that the Wall Street uses to measure companies. I spend a lot of time in front of customers talking about their ESG goals and how can we help meet those goals. So spend a lot of time there. Electrification. I think everybody realizes that the transport industry is going electric between now and 2050 at some rate. We're not quite sure what. That would include fuel cells. So the industry is electrifying. It's just a matter of how and when. And then Destination Zero is Cummins' answer to our ESG goals, right? So you see that at the very bottom is very small, Planet 2050. That's Cummins' goals to be zero carbon in our operations, in our production, and in the products that we produce. So, and Destination Zero, we're starting today to reduce carbon, not when we think we have the perfect technology. We're going to do everything that's required. So between now and 2050, and different buckets, 2021 to 2023, drive reductions in NOx, create technology that's regulatory environment. So we're doing that today with our clean diesel, our natural gas, our hydrogen internal combustion engine technology. And then many solutions are going to be segment by segment. So we think electrification is going to happen in the light duty and medium duty business first, then in Class 8 later. New infrastructure fuel is going to be deployed. So you're going to see corridors for EV and for hydrogen come online between 2030 and 2040. And then by 2050, we think a lot of the technology will be mature, including infrastructure. Hydrogen infrastructure will definitely be mature by then. So a lot of stuff going on. So the power of choice. And so talking a little bit about all the technologies and positioning and where the pros and cons and so forth. So diesel, king of the hill. It's been around for 100 years. Does a very good job in all applications. But it's very difficult to clean it, right? There's a lot of carbon in diesel fuel, and there's only so much we can do to reduce NOx and PM. So we've got these engines extremely efficient, extremely clean, but you can only do so much. And to get them to 0.035, the price of the engines the engine systems is going to go up, no doubt about it. Natural gas has been around for a long time, near zero emissions, carbon negative with renewable natural gas, low total cost of ownership. You can see the different applications there, transit, vocational, regional haul, and then with our new engine, which I'll discuss in a moment, long haul. And the challenges are it's expensive. The fuel system is not cheap, and the infrastructure is not everywhere. Natural gas is not available everywhere. Hydrogen, ICE, internal combustion, zero carbon. There is no carbon in hydrogen. So it's fast fueling, long range. So it basically covers the whole range of applications that a diesel would. High initial price. It's going to be a very expensive application when it comes out, and the infrastructure is very limited, right? Gasoline and propane, they're a medium duty play. Gasoline is a NOx. It's not really a sustainability. It's not a carbon reduction technology, but it's for places where diesel is a challenge or natural gas is not really applicable. Propane is a great technology, very specific applications. You can get renewable propane out there. We think it has a definite play in the propane delivery business, maybe in beverage, possibly in U.S. mail haul. Then battery electric or BEV, and then fuel cells. So battery electric, zero emissions, right? So low maintenance, has a bunch of applications. Challenges are battery weight's very heavy, range isn't very good, charge times are long, and upfront cost is eye-watering. And then double down on that with hydrogen, zero emissions as well. Fast fueling, long range, has lots of applications, very expensive, but we think that this is the technology that will replace diesel engines in long-haul trucking, as Mike was talking about. So I'm going to switch to the engine side, and then I'm going to come back to the zero emissions stuff. So Cummins has developed what we call fuel agnostic platforms. So it's basically an engine platform that the base of the engine is the same, and then the fuel system is different depending on the fuel. So we have engines that run on natural gas, diesel, and hydrogen. Below the cylinder head, or the cylinder head deck is the same, and then above it is specific to the fuel. There was a question last night at the reception about, are these dual fuels or tri-fuels? They're not. You can't switch back and forth. It's certified at one, and that's all you're going to get. But basically, it makes it much easier for a truck OEM to do the application engineering to fit the engine in their chassis, and then the fuel system is sort of just depends on what the customer wants. So, the three main platforms that we sell in North America, the B, which is 6.7, the L is 9, and the X is 15 liters. And these are the fuels that you can potentially, or we will run. So I'm going to concentrate on the 15 liter today, but we have diesel fuel, natural gas, or hydrogen. Oops. Okay, natural gas. So on the left, we have 6.7, 9, and 12 liters. These engines have been in production for years. And will continue to be in production, but for this discussion this morning, we're going to talk about the 15 liter. It's a new engine, it's coming out next year. And so what is the environmental sustainability benefits, economic benefits, and operational benefits. I'm not going to go through everything, but lower greenhouse gas and NOx levels, potential to reach sub-zero carbon with renewable natural gas, low cost of fuel. So a DGE, or diesel gallon equivalent of natural gas, is in the below $2. I've seen it as low as $1.50. Diesel fuel is around $5, so you can do the math. That's a big darn deal. Much lower incremental vehicle cost than a battery electric vehicle. So a natural gas truck, roughly between $50,000 and $70,000 more than a diesel truck. EV is 3x times the diesel truck. It's like $500,000 for a Class A truck, so a lot of money. Least disruptive, so you can run 10 hours. You can run 2 shifts with natural gas. It feels just as fast as a diesel truck, and so it's suitable for multi-shift operations. NOx levels, 90% below EPA standards. So our engines already meet the 0.2 grams of NOx, so they meet the 2027 rules today, have for several years already. PM, same thing, 90%. Carbon dioxide CO2 levels are 16% below EPA standards, and with renewable natural gas, you can get 90+% reduction in CO2. And this is sort of explains a little bit how that works. This is a low carbon fuel standard for California. And if you use diesel fuel as a baseline, it has a carbon intensity score of 100. And this takes a huge plot point of different sources of fuels to get these numbers and their averages. So fossil natural gas is 81, propane is 36, electricity is 26, because most of the electricity is generated using fossil fuels, natural gas specifically. The average for renewable natural gas is -92. And depending on the source, if you're using agricultural waste, there are sources that are in the -300 to 400 range. So if you know anyone who has a farm with cattle, chickens, hogs, etc., tell them to reach out to a fuel provider. They'll probably put a digester on it and they can generate revenue for their operation. It's a huge deal. 100%, close to 100% of the California mobility with natural gas is RNG, and across the country it's in the neighborhood of 60%. So see some applications for natural gas: truck, transit bus, refuse and vocational, school bus, not so much. It's sort of being replaced by battery electric, propane, gasoline, and some diesel. But it was a big play for a while, but it seemed to have seen. But on the left, you'll see UPS truck, Waste Management, Amazon. Those are 3 of our biggest customers. UPS has 7,000 natural gas trucks. Waste Management has in the neighborhood of 16,000. They generate their own fuel with their landfills. They make money from the trash, and they charge you to pick up the trash that they make fuel from. It's an amazing business model. Amazon's got 4,000 or 5,000 natural gas vehicles, and they've made a commitment to continue to buy. So hydrogen engines. So like I said, agnostic platforms, right? So we have the 15-liter, runs on natural gas. That's coming out next year. In 2026, there's a new diesel version, the 15-liter, and then in 2027, we're going to have a hydrogen internal combustion engine out. And this applications, regional haul, long haul, et cetera. We have a 10-liter that will potentially be out in the 2030 timeframe. And then we have a 6.7. We're not sure if we're going to produce it or release it here in the United States. That node of business could be taken up by EV. But in India and other parts of the world, propane is a big darn deal. And or hydrogen, I'm sorry, hydrogen is a big darn deal. And so that may be a global engine that we sell offshore. So, but these are the 3 platforms for hydrogen. And so this is sort of a mock-up of what a hydrogen truck looks like, right? So you got an engine in the front, and you got transmission, and you got mechanical drive axles in the back, and what you have behind the cab is a hydrogen fuel tanks. Much similar, actually, to natural gas. Natural gas tanks are 3,600 PSI. These will be 10,000 PSI, so quite a bit higher. The initial cost to be competitive with other technologies, zero carbon with green hydrogen, and so this will help, we think, drive the hydrogen infrastructure if we generate demand today or soon for hydrogen, which will help drive the fuel cell business in the future. And so this is a side-by-side of a hydrogen engine truck and a hydrogen fuel cell. So same tanks set up, right? Multiple 10,000 PSI cylinders. The engine, the hydrogen engine, transmission, it's just a truck, right? It looks like a truck, feels like a truck. Not much different than today's technology with that. The fuel cell a fuel cell truck is basically a battery electric truck with a fuel cell range extender. So you take out some of the batteries, you still need some to help with propulsion, but also for regenerative braking. So the fuel cell sits in the front where the engine is. You have batteries where the fuel tanks on a diesel truck are. You have vertical hydrogen tanks, and then you have electric axles in the back. So I wanted to talk a little bit about the alternative power business. So Cummins spun off what we used to call our new power business and is now called Accelera. And so it's where all of our zero emissions technology sits. And so it helps us delineate between the diesel internal combustion business and zero emissions. And so this is sort of a menu of the technologies that they offer. So electrolyzers, right? That's how you create hydrogen. You run electricity through water, H2O, you split the hydrogen and oxygen, and you capture both. Fuel cells does the opposite. It takes hydrogen and oxygen, puts them together on board a truck, and creates electricity. And then the electrified components, e-powertrain systems, and traction systems is all the bits and pieces of electric drivetrain that you would need, inverters, batteries, e-axles, all that stuff. So this slide is more or less focused for an OEM to say, from soup to nuts, we can provide you with a solution for zero emissions, whether it be fuel cells, electrolyzers, et cetera. So this is Cummins Accelera core technologies. And tomorrow, Ryan Suku, my colleague, is here, and he's going to go into a deeper dive on all this stuff. And so here's some real-world experience, and I think this is my last slide. So battery electric works really well in things that come home every night and can slow charge. School buses, pickup and delivery trucks, terminal tractors. Those things run 24 hours, but anytime a guy stops for a cup of coffee, they do opportunity charging outside the cafeteria. Class A trucks, not so much, not yet at least. Transit, and then, of course, industrial. Fuel cells work better when range is an issue, right? So passenger trains, we actually have fuel cells in production in Alstom trains in Europe, running passenger service. Class A trucks is a perfect thing. Longer range or range requirements for longer transit bus routes. Ferries, so there's a marine business potentially, and believe it or not, aircraft. And then, of course, electrolyzers, which is part of hydrogen generation. It's almost more of a power generation side of our business. But if you wanted to create hydrogen and you had a source of water and you had a source of green electricity, you can make it. I mean, so in theory, a truck stop could. I mean, it's not something that has to be off-site in a huge industrial operation. It could be made locally too. And of course, hydrogen refueling and blending. So that is the Accelera portfolio in a nutshell. So I think that's all I have. And now I guess we can answer any questions that you may have.